Hi everyone, Miss B here. Today we're gonna do a little bit of differentiating using simple rules of differentiation. So one of the rules here is differentiating a constant f of x is equal to c, derivative f dash of x is always equal to 0. The second one is differentiating x to the power of n could be any number. So for example, f of x is equal x to the power of n. Differentiating this, f dash of x is going to be equal to n, which was the power of the x here. So we're going to write that in front of the x, and the power here is going to of x is going to be reduced by 1. So the third one is if we do have constant times a function, for example, f of x is equal c times x to the power of n. Pretty much f dash of x is going to be equal to c, you copy the constant, times n, which is the power of x, then times x, and then you reduce the power by 1. So the last one is addition and subtraction rule. So if we have f of x equal u of x plus v of x, so addition of two or more functions, or subtraction. So how are we going to find the derivative? F dash of x is pretty much we do differentiate term by term. Okay, so this is, like a lot of letters. Let's go with some examples. And okay, so the first one I'm going to have here is f of x is equal to 5. So this is the same as y. So I'm saying this because if I say this is equal to y, so that's my point, y equal to 5. If this is 5, and I'm going to have a line, straight line going through 5. And if we just look at this, we can see that slope is equal to 0. So therefore, y dash or f dash of x of 5 of the constant is equal to 0. If you do want another example, so we're going to go f of x is equal to 3, f dash of x is equal to 0. So this is using the first rule, differentiating a constant. Now let's have a look at some examples when we have, for example, y is equal to x to the power of 5. So this is the same as equal to f of x, okay, just to remind you. So f dash of x is equal to, according to this rule, so the power here needs to be written in front of the brackets, in front of x. So it's 5 and then times x. And this same power here is going to be reduced by 1. So it's going to be 5 take away 1. So you don't have to write always, take away 1 from the index. So pretty much you can do that in your head when you feel confident doing it. Okay, next example, y is equal to 3x to the power of 4. So y dash is equal to, now this one is the, when we have constant times a function. So how are we gonna differentiate this? According to this rule here, so constant is in front of the power. So it's just going to be 3 times, and the power it's 4 times x, and now the power is going to be decreased by 1. So this 4, it will be decreased by 1. So it's going to be 4 take away 1, it will be 3. So if you do want to simplify this, pretty much you can say 3 times 4, it's 12, 12x to the power of 3. So now one more example with this one here. So f of x is equal to negative 7x to the power of 2. F dash of x is equal to, again we have a constant times function. We just write down constant, copy down, then times the power, which is times 2, times x, and then this power is going to be decreased by 1. So it's 2 take away 1, it's going to give you 1. So simplify, negative 14 and times x. So now let's have a look at maybe addition and subtraction rule by doing more examples. So let's have a look at this one. So y is equal to x to the power of 2 plus 3x to the power of 4. So y dash is equal to. So what we're going to do here, we're going to use the rules that we have already seen and used and just apply at each term. So we do differentiate term by term. So derivative of x to the power of 2, we copy 2 in front and then times x, and the power of 2 is increased by 1. So it's going to be 2 take away 1 is 1. Plus, now we do have constant time x to the power of 4. As you have seen before, you write down 3, you copy the constant, then times power, which is 4, and then times x, and this power is going to be decreased by 1, so 4 take away 1 is going to be equal to 3. And if you do want to simplify, you can go 2x plus 12x to the power of 13. And if you do want to factorize, you can do that as well, but often you haven't been asked to do this in differentiation. Sometimes you have to show it's equal to this, and then you do actually simplify a little bit more. Now, let's have a look at another one. So, y equal to 1 over x, take away 5 over x to the power of 3. The first thing that we're going to do, we're going to rewrite this in a different form, so no fraction. So 1 over x is the same as x to the power of negative 1. Please remember, on the side, 1 over x to the power of n is the same as 1 times x to the power of negative 1. So if I have 2 here, that's 2 there, because sometimes kids get confused and take away n. Okay, let's go back to this. Let's go back and change this one a little bit. Yes. Okay, let's try that again. To remember to use the rule that 1 over x to the power of n is the same as x to the power of negative n. If I have 2 over x to the power of n is 2x to the power of n. So index law. And then take away 5 times x is to the power of 3 here. Move to numerator, it's going to be negative 3. Please note, this is just, a different way of writing this function. So, but now we're going to do differentiation. Y dash is equal to. So let's focus term by term. X to the power of negative 1. So we're going to take negative 1 in front. Negative 1 times x. And now the power here is going to decrease by 1. So it was negative 1. So negative 1 take away 1. Take away 5 is a constant times negative 3x. Negative 3 take away 1. As I said before, you don't always have to have negative 1 take away 1. So if you do feel confident, you can just skip that step. Negative 5 times negative 3 is plus 15. X and negative 3 take away 1 is negative 4. So if you do want to have this in a little bit nicer form, this one is nice as well, but if you do want to have positive index, so it's negative 1 over x to the power of 2 plus 15 over x to the power of 4. Okay, let's move on to another example. So let's have a look at this one here. Y is equal to x to the power of 2 take away 3 over x. And it's like, oh my God, any rules that I have seen so far, I can't use. So there are some rules that can be used, but at this stage, you haven't been introduced to those. So what we're going to do, we're going to, rewrite this in more friendlier version. So pretty much we're going to split the terms, because x is common for x to the power of 2 and it's also common for negative 3. So, and at this stage you're looking, can you cancel out something? Yes, you can. X and 1x there. So you're going to be left with x, negative 3, and now this x we want to move to the numerator, and it's going to become x to the power of negative 1. So again, just remember, this is just different way of writing this function. Now we're going to differentiate. Y dash is equal to derivative of x. So it's going to be power is 1, and then x, you copy x, and because power was 1, 1 take away 1, take away 3 times the power, which is negative 1, x, and reduce this power by 1, which is going to be negative 1, take away 1 is negative 2. Now what's happening here? 1 times x to the power, 1 take away 0, take away 3, negative 3 times negative 1 is 3, x negative 2 equal to x to the power 0 is 1, so and plus 3, and if we want we can move this into denominator in order to have positive index. So that would be the final answer for this question. Now what about if you see the question like this? Y is equal square root of x. Is like, okay, you know, I do know there's a power rule, so what can I do with this? So what we can do is actually rewrite square root of x in index form, power form. Now it's easy, isn't it? It's like, let's use blue. Y dash is equal to, write the power in front, it's half. So times x and power half, take away 1. It's going to give me what? Half x, half take away 1 is negative 1. Again, you can rewrite this and put this in denominator, and you're going to have 2 x to the power of positive half, or you can have 1 over 2 square root of x. So I think I may do one more. Let's have a look at this one here. Y is equal to 1 over x times square root of x. So what I would do here is I would actually rewrite x and times x to the power square root of x in index form. So it's x times x to the power of half. Now if I simplify this, it's going to be x times x to the power of half, the same base, and we add the indices. The index here is 1 and here's half. 1 plus half is 3 over 2. So that step is done. So now we can say, okay, so this is still equal to x to the power of negative 3 over 2. Now it's easy to differentiate. All we're going to do is y dash is equal to copy the power in front of x and then times x and reduce this power by 1. So it's going to be negative 3 over 2 x, negative 1.5 take away 1 is negative 5 over 2. So you can leave answer like this one, or if you want you can move this x to the power of negative 5 over 2 in the denominator to have positive index. So it depends on what you have been asked. Okay, so that would be all for now for simple rules of differentiation. Bye.